Okay, so in this video, we're going to be talking about how to find the square root of I. Now, if you're on this video, you probably already know that the square root of a -1 will be equal to I, and we know that -1 is equal to I squared. But what happens when we take the square root of I? Now, this problem is great because you can actually figure out the solution just by using algebra, and that's why I love this example here. So let's talk about how we're going to do this problem. Let's go ahead and get rid of all of this here. And first, we have to talk about I. How can we represent I? Well, we know that I is going to be an imaginary number, and we can represent that as A plus BI, where we have our real part and then our imaginary part right here, BI. So we can represent I as A plus BI. And so think about this. If I were to take the square root of A plus BI, will I still have an imaginary number here, or in other words, a complex number because I have a real part and an imaginary part? Well, you will still have a complex number here. It's not going to change. Regardless if you take the square root, you will still have a complex number here. So what I can say is the square root of I is going to be equal to some complex number, A plus BI. So what I'm going to say is the square root of I is equal to A plus BI. And then from here, we're just going to go ahead and start solving for I and see where it takes us. So in order to get rid of the square root here, we're going to square both sides. Okay, so then I get I is equal to A plus BI and then squared, right? Again, I'm just squaring both sides. And then from here, we want to go ahead and expand this out. So you can use FOIL here, and you can also do it in your head. If you do it in your head, you're going to get I is equal to A squared. And then doing outside and inside, you'll get ABI, but you have two of them. So plus 2ABI. And then doing last, you get plus B squared, I squared. Now remember, I squared is really -1. So this part right here, I can replace with a -1, and I end up with negative B squared. So I get I is equal to A squared plus 2ABI. And then minus B squared. And so now you have an equation, and you have real parts and you have imaginary parts. So my real parts are right here, A squared and negative B squared on the right-hand side of the equal sign. Now on the left-hand side of the equal sign, it's not obvious, but you actually do have a real part. It's plus 0, right? So my real part on the left-hand side is going to be 0. So I'm going to go ahead and underline that. So remember your rules when solving equations when you have real parts and imaginary parts. You want to keep the real parts together, and then you want to keep the imaginary parts together. So for example, I can actually derive two equations here. By keeping the real parts together, I'm going to get 0 is equal to A squared minus B squared. There's one equation. The other equation is going to come from keeping the imaginary parts together. So for example, this part here, and this part here. So my other equation is going to be I is equal to 2ABI. Now remember, I don't technically have to write the i's here because I have them on both the left-hand side and the right-hand side. So naturally, they are going to cancel each other out. So this will cancel, this will cancel. I'm left with 1 on the left-hand side. So I'm going to go ahead and rewrite our two equations in red. That way we can see exactly what they are. We have 0 is equal to A squared minus B squared. And then again, canceling out the i's, we're left with 1 is equal to 2AB. Because remember, there is a 1 in front of that I. And so at this point here, you have a system of equations. So what we're going to do is solve for A and B. Once we have A and B, we can write it as a complex number, and we're going to have our answer. Okay? So let's go ahead and do that. And I'm going to go ahead and label my equations. Here's equation 1. Here's equation 2. I'm going to go ahead and solve equation 2. I'm going to solve for B. It doesn't matter which one you solve for, but I'll solve for B on equation 2. And if you do that, you get 1 over 2A equal to B. So now that I have my new equation, I'm going to take that and plug it into my first equation right here where I see a B. So let's go ahead and do that. Let's scroll down. And so doing equation 1, we get 0 is equal to A squared minus, now here comes my B, I have to plug it in. I have 1 over 2A, and then I have to square that. And then we're going to go ahead and solve for a here. So we get 0 is equal to a squared. Remember, this exponent has to be applied to both your numerator and denominator. So when you do that, you get 1 squared, that's 1. 2a squared is going to give you 4a squared. So I'm going to rewrite this as minus 1 over 4a squared. Now from here, we want to get a common denominator. I see that I have 4a squared here. I also want to get that right here. Now this a squared is really over 1, so I simply just have to multiply both the numerator and denominator by 4a squared. If you do that, you get the following. You get 0 is equal to 4a to the 4th power all over 4a squared. And again, I'm just multiplying the top and the bottom by 4a squared there. And then minus 1 over 4a squared. And so we can go ahead and write the numerator as 1 now, all underneath the same denominator. So 0 is equal to 4a to the 4th power minus 1 all over 4a squared. Now this part you have to think logically, okay? How do I solve for a here? It's not going to be very obvious. But if you think about it, my equation here is being set equal to 0, meaning my numerator must be what? Well, it must be 0, because that's the only way I'm going to get 0 for an answer, because 0 divided by anything will be 0. So I know that on my numerator, it will be 0. So in other words, what does a have to be in order for that to happen, in order for it to be equal to 0? So all I'm going to do at this point here is take my numerator, set it equal to 0, solve for a, and then I'll have a. So for example, you're going to have 4a to the 4th power minus 1 equal to 0. And then you're going to solve for a. So let's go ahead and scroll down. And from here, I'm going to go ahead and add 1 and divide by 4. So you get a to the 4th power all over 1 over 4. And then we have to take the 4th root on both sides. So let's go ahead and do that. We get a is equal to, now when you take the 4th root of 1, that's just going to be 1. So I put 1. And then you have to take the 4th root of 4. So I'm going to put the 4th root of 4. And remember, my index here is even. So like this is very similar to when you're taking a square root, which has an index of 2. It's going to be plus or minus here. So make sure that you're putting plus or minus, because again, you're taking the 4th root. That index is even, meaning it will be plus or minus. Now this part right here, we have the 4th root of 4. Think about how we can simplify this down. And first you have to know your rules for square roots and how to rewrite them. So for example, if you have the square root of x, I can rewrite that as x to the half power. And remember, on a square root, it does have an index of 2, even though they typically don't write it. Well, I have a 4th root. I have a 4th root, and we'll just say of x. I can rewrite that as x to the quarter, right? And so you can actually rewrite it as an exponent, okay? And that's what we're going to do here. So getting rid of all of this here, and just looking at my denominator, I have the 4th root of 4, and this 4 right here, I can rewrite as 2 squared. So for example, the 4th root of 4 and then 2 squared, and then rewriting this 4th root as an exponent, what will happen here? I get equal to 2 squared all to the quarter power. When I multiply my exponents here, I end up getting a half. So I get 2 to the half power, which is the square root of 2. So a is equal to plus or minus 1 over the square root of 2. And if you really want to, you can go ahead and rationalize that denominator. To rationalize it, you just multiply both the top and the bottom by the square root of 2. So you get plus or minus square root of 2 all over 2. Okay, so that is a. So now that we have a, why don't we go ahead and change the page and we'll solve for b, and then we'll pretty much have it. Okay, so we're on the next page here. Again, I have a, I have both of my equations. All we have to do now is plug it into one of our equations and we can get b. I'm going to go ahead and plug this into equation 2, and I'm going to do it in 2 different parts. I'm going to use the positive version first. I'll get an answer for b, and then I'll use the negative version, and I'll get an answer for b, and then I'll be done. All right, so plugging it into equation 2, we get 1 is equal to 2. Now here's my a. I'm going to use the positive version first. So square root of 2 all over 2, and then I have b. Now this works out nicely. The 2's will cancel here, and I get 1 is equal to the square root of 2 and then b. And then just simply divide both sides by the square root of 2, and you get b is equal to 1 over the square root of 2. And if we rationalize that, we get the square root of 2 all over 2. And so that's one answer. And I can say that right here, the square root of I is equal to, well, I plugged in a square root of 2 all over 2 into A, and I returned a positive square root of 2 over 2 for B, so plus square root of 2 all over 2. But remember, we're writing this as a complex number. I do need my I here. So there it is. Remember, A plus BI. So A plus B and then I. There it is. Now, let's go ahead and do it for the other version, the negative version, and we'll see what we get here. Let's do this one in a different color. So we'll get here 1 is equal to 2 times, and then we get negative square root of 2 all over 2, and then B. Again, the 2's will cancel. Here I get 1 is equal to negative square root of 2, and then I get B here. Divide both sides by negative square root of 2, and you get 1 over negative square root of 2 equal to B. And then we can rationalize our denominator. So we get B is equal to negative square root of 2 all over 2. And there it is. So there's the other part. So let's go ahead and write down our last answer here. So the square root of I is equal to, again, I plugged in a negative square root of 2 all over 2 for A. And I returned a negative square root of 2 all over 2 for B. Don't forget your I, and there it is. Okay, so here's our answer. All right, so that is the square root of I. Again, we used algebra to solve that, and that's pretty much it. So I hope that you found the video helpful. I hope that you gained something from it. If this video did in fact help you, if you could just go ahead and give it a thumbs up, that would be greatly appreciated. Also, make sure you subscribe, that way you get more math videos in the future, and I'll see you in the next one.